Well, welcome back to the channel. Today I got a project that I'm pretty excited about. We're going to do some work on this Dodge D44 front axle. Yeah, it's out of the truck again. So it actually occurred during a catastrophic failure mistake on my part. And what happened, this is what happens when you don't put enough oil in your differential. It's just a rookie mistake. It wasn't that I didn't put any oil in the front differential. It just comes from inexperience. And that's what you're going to run into. You don't like it. But what happened? You know, I put that ARB locker in there, and I have two fill holes on my diff cover. The bottom one is like for the factory fill level. I went and I filled it up. Oil's coming out of that hole. I thought, okay, well, it's that full. Put the plug in, and then I have another plug, another 2 inches higher, and I put about 15, 20 extra pumps of oil in there. A little overfill, at least I thought. And what I think happened is there must have been like an air pocket or something in the ARB, and it wasn't like allowing the oil to go in there, at least not at a very fast rate. Maybe it was just trickling in there. So it fooled me. So learn from my mistake. When you put your oil in those differentials, go over there, pull it off, you know, get it on jack stand or something, rotate the tires, get that oil mixing in there, wait an hour or whatever, and come back and check it. Because when I checked it, the oil was super low, and essentially the ring gear was not able to fling enough oil forward and into that little pocket for the pinion bearing. And that bearing was seized on there so much, I had this 20-ton press over here. I was hanging on the bar, 40,000 pounds of pressure, wouldn't budge, absolutely wouldn't budge. I got my oxyacetylene torch out, heated the bearing up, and there's little pops and cracks here, and I left it on there for an hour. Nothing, it wouldn't go, it was seized. So at that point I decided, I think the metallurgy on that pinion gear is probably corrupted. And I decided that the only way I get it out is I had to use the torch. I had to cut the bearing, and that's why it's all chopped up. And once I got about two-thirds of the bearing knocked out, I was able to bang it with a big hammer, and it could pass through the bearing race and come out of the housing. So, but I said I had to spare the housing. I did. No damage to that. And I thought, well, there's one project I wanted to do. I was going to do it like next year. And then it just exploded on me. And that is to do a CAD delete. CAD, central axle disconnect. Let me show you. So this is the CAD right here. And essentially, I went on the internet and I looked on YouTube to see if anyone has done a CAD delete the way I'm going to do it, and no one has actually recorded it. At least I couldn't find it. So what they usually do is they take this housing and they'll do a solid axle all the way through and just put a cap on that, call it a day. And that's a CAD delete. The other way to do a CAD delete was the way I did it. Let me show you how I did it. And it's not really a delete. It was basically, here's the two-piece axle right here. And then this collar, you know, it slides back and forth depending on if you want it four-wheel drive or not. And then this piece, that's shift fork. All I did was make the shift fork so it wouldn't slide back and forth, and it would go on there and hold that collar and make this, you know, stay in it would connect these two rods and run full time. So that was another style of CAD Delete. But I went over to Tahoe Overlanding, and they have a really nice CAD Delete kit just for this. It's also hard to find it for Dana 44. There are CAD Deletes for Dana 60s out the wazoo, which is just a chromoly shaft all the way through and a cover. And they do something with the seal, because there's actually a seal right here on these. Tahoe Overlanding does a thing where they make a sleeve, and it's got about a 5/1000th diameter tolerance, he said, and it sleeves all the way through the CAD, all the way up to here. And then they've got some other stuff you put in here to put in a standard Dana 44 inner seal for a standard Dana 44 shaft. So actually the seal now on this side is exactly the same as the seal on the short side. Really clever. And then they also, you know, they drill some 1/2-inch holes in the tubing and over in here, and they do some special instructions for tying the CAD to this inner sleeve, and, you know, do those plug welds. But additionally, he has a piece that goes into here and welds to the tube here, and then the cover has a slot in it. And when you put the cover on and you use these 4 bolts, plus you add 2 more here, and then you actually weld this piece to the cover, and it helps tie that inner sleeve to everything in here. And I thought, well, pretty cool. But I wanted to go one step further. I told him what I needed to do was an inner C cut and turn. So essentially, I want to take these inner C's on both sides and cut the tube and then rotate them actually this direction. And the whole point is to take this pinion and point it up higher, because I'm currently running at about 10 degrees on that U-joint for that front drive shaft. It was turning smooth, but you know, at 10 degrees, they're not meant to do that. They like to run at, you know, about 3 degrees or less. So I was going to definitely get some premature wear. And I'm like, I want this thing to be reliable. And so if I can rotate this up, then that'll take care of it. I can almost zero it out. I think if I get my measurements right, it should actually run at 0 degrees on right here on the front of the differential. And then I let the double cardian take care of the rest of it. And I'll be running at 2 degrees positive caster here, which is the way this is all set up. So the hard part, actually the hardest part is the short side, because this bracket doesn't really give you any room in here to cut it. So I'm thinking, I was suggested to cut it here, and then he gave me another sleeve that's actually going to go inside this here, and then I could just cut it, rotate it, re-weld it. But you know, to get my welder in here, not really feeling comfortable with that. So I'm going to remove this bracket as carefully as I possibly can. But when I put it back on, I have to make sure I maintain the relationship between this inner C and that, because what happens is your shot goes down in here, and if I got this thing twisted, you know, 4 or 5 degrees out of what it's at, when I put it back in, I won't even get the shock mounted in there. It'll be all bound up. And also over here is the mount for the track bar, and that track bar will also get bind. So I want to keep all of those relationships the same as when I took it out of the truck. So when I cut this off, I got to make sure that I weld it right back on, you know, plus or minus half a degree, and I probably won't have any problem. So anyways, that is the project. I'm actually still waiting on parts. They're oncoming, but the special part is, in this case, I'm actually going to do a CAD Delete. This casting is going to be removed. It's It's gonna be gone. And then where there's a gap in here, you'll see it when I get the kit. He's got a way to fill that gap up using the inner sleeve, and we'll get it all welded up, and it should look just like a, old school Dana 44, that had, manual locking hubs, except this will not have manual locking hubs. It'll have the nice wheel hub bearings out on the outside, which are stronger than locking hubs anyways. So that's the project. I don't have the parts, but I can definitely get started. I need to cut that off. Oh yeah, also chromoly inner shafts, both sides. So my weak point is going to be U-joints and ring and pinion. I think, so I'm excited about this project. So right now, I'm just gonna go take a bunch of measurements, get some angles, make sure that I can put this thing back together and not screw it up. Now this is something I've never done before. It's probably not outside of my wheelhouse. And this is definitely not a how-to tutorial. This is just me trying to figure this out. And it's my hobby, and I feel pretty comfortable with the whole process. And one of the debates that I had with my parts supplier was, you see a lot of videos, they have a bar that goes all the way through the whole axle, and that bar has some pucks both on the ends, and it has some that go inside the housing, and it's an alignment bar. And I was thinking about that alignment bar, and that alignment bar doesn't actually, if you look at them, they have some flex to them. A lot of them I've watched over and over again, the bar moves. So it's not like a fixture, right? But it will tell you if, your heat is warping that tube enough and it's getting out of alignment, and you can try to heat it, or at least you can correct it. You'll know there's a problem. And if you have a problem in your welding, you can always cut, straighten, re-weld. You have that. But on a front axle, the debate was, is alignment bar really critical? And if you've seen the U-joints rotating inside the knuckle here, it's doing this, it's doing this, it's all over the place. So then again, on the front end, you can set your camber. People think camber is fixed on a solid axle. No, I have a ball joint down here that you can adjust the camber plus or minus 1 degree. So it's got 2 degrees of movement. And then there's other stuff you can buy that goes in the top part of the knuckle, and you can actually buy these little camber inserts, and you buy them by how much degrees you want to affect your camber. So no, they're not built to do that from factory, not all of them, but there's aftermarket stuff that you can do for camber. And then also toe on the front. You can adjust your toe on a front axle. So really where it's critical, because you can do all that in alignment, where it's critical is a rear axle. Because once you weld it, if you welded some toe into that, that's what you got. If you welded it and it put some too much camber in it, there's no adjusting that. So with a rear axle, especially like if you're in a high-speed racing application, you're going to want that thing super straight, especially like in drag cars where they just hammer down, because it'll pull you to the left or the right, or it'll do some stuff that you don't want it to do, and you won't have that nice control under hard, heavy power on your race car. But so after some debate about doing, cutting up my axle into like 4 pieces, because that's what it's going to be, and then I got to put it back together. I realized that having it dead nuts perfectly straight is probably not going to be a problem. And with 5 thousandths tolerance on this inner sleeve, it's just going to go on there. It's going to have a nice, just rotate it, make sure I got the length correct for the width, and just tack it, check it, tack it, check it, and then weld that sucker together. And so my only fear is massive warpage. But other than that, that's what's going on. And I hope you guys enjoy this video, and I hope it goes well for me. Well, I did get it off. It was a fight, and let me kind of show you what I was working on here. I tried grinding, and the one real booger weld was this guy right here, because it's right up against the case. So that one I was actually able to get the grinder on and weaken it, and then I got the plasma from the inside, blew it out. The rest of these I did some grinding just to weaken the weld as much as I could, but really plasma or oxyacetylene torch, that is the only means to success. All right, well, so I got all these stuff cleaned up. You see there's some pretty decent, gouges in this. But all that slag and stuff left over from cutting it, you don't want that in your weld, because that's really weak stuff. Oh, air compressor going on. So yeah, I took just a big grinder and just started, cutting it out, cleaning it up. And even in here, got it pretty good, because it's really hard to get that torch in there. This was just a nightmare area. But I'll go ahead and fill these up with weld, and then smooth them out, and then this will be restored. If you think that I'm weakening this, well, in a way, but as much as I'm taking out, remember, I'm putting a 1/4 inch sleeve inside of that, so I'm adding a 1/4 inch, and this is not like a Jeep axle. Look right here, get some light. This tube, it's just shy of a 1/2 inch thick right there. That's not no 1/4 inch, so I'm gonna add a 1/4 inch to that thickness. Probably going to be probably not quite 3/4, but maybe a little more than 5/8. So would that be 11/16 maybe? But plenty of strength on it. So when I put the sleeve in there, then all the damage that happened up here taking that bracket off, I'm not that concerned about. Plus, this is a nice short section, so it's plenty stiff on that. So anyways, I'm going to get to it and be right back. So here, looks like I got all the things all welded up. See, just dropping it on there, nice hot weld, it's all filled up. So I'm going to let this cool off for a bit. Go all the way around. See it right over here on this side too, underneath. It's all done. So getting closer to having this side prepped. Well, here it is. It's all welded up, all cleaned up, nice and smooth. I actually went ahead and took all the paint off this. It had a lot of rust on it. This thing was out of South Dakota. I believe it's part of the Rust Belt, and well, it was. I mean, yeah, look at the rust here I'm still dealing with. Anyways, this part is done. It's all cleaned up. This is ready to do the cut and turn, but I'm not going to do that until I have all my parts. Well, since a second ago, it's actually been several weeks, and it's winter now, so things are a little bit different. It's all raining and everything outside. So this axle is time to cut. So let me show you a few things that I've done to prepare it prior to cutting and to show you those details. So first thing you notice here, there's a couple of 1/2-inch holes. Yeah, we're gonna do those welds. When the sleeve's in here, I want to go in there, weld that sleeve in, and it'll be a little tight. And I have 2 holes on the back. So 4 total, that's all you gotta do. To drill those, you know, you could do this thing with the axle in your vehicle, but let me tell you, you gotta, with drilling, lots of drill oil, push real hard and slow. Because as soon as you get the tip of that drill bit hot, you just lost its temper, it won't cut no more, and you gotta go get another drill bit. So keep it a lot of lube, slow, get it in there, and yeah, so it took me some work. So I was actually standing on top of this workbench, and then, you know, that had the drill pushing down so I could use my weight in order to help me not just push arms only. And then I just marked, this is a pretty random line, you know, it had just to be somewhere in here. And all you do is just get a piece of paper and you wrap it around till the ends come together, and then you just follow the line of the paper. It'll give you a really nice squared up line. The other thing I did, as you can see this top line, and a nice piece of angle. It's nice because it squares up to the tube real well, and it'll always give you a nice straight line on there. And that's just to give me a reference that once I cut it, then I can put the sleeve in here and get it back together so it's close. And then I want to set the rotation back to factory. And then when I rotate this, I will rotate it. I'm thinking I'm going about 8 degrees. And then you'll see these lines, this line will rotate that way, and they'll separate. And I've got a thing up that I can put up here for an angle finder, digital angle finder. But you're gonna wanna have this point of reference. The other thing you can see here, maybe right there, there's actually a little shiny dot. And then right there's another one. And then right there, another one, and another one right there. So if the line gets washed off or whatever, comes off, I can just reestablish those lines. In fact, even when it's cut in half, I just put this on there with those dots like that, and I can redraw it in, and then put it on the other one, even though if this, you know, if it's cut in half, it doesn't matter. Now there's several ways to cut this. I'm going to start with a grinder and just do me a nice groove all the way around. But you can actually cut it with a regular bladed saw, reciprocating saw. You know, there's a bunch of ways to do this. And you don't have to cut this like super clean and straight through, because when you're done, you're going to have to chamfer both edges. And when you chamfer them back, that's great, because you know you want to get good weld penetration. And plus on one side, you probably want to go out maybe 1/8 of an inch or more, so that you actually see the insert tube on the bottom is plain. So you're going to be welding to the tube and then moving that weld pool to both sides as you start to glue this thing, you know, back together. Yeah, one more thing. The tube insert for this. You got the long one and the short one. And I measured this one. It's exactly 12 inches long. And if you go out to the inner axle seal, which is currently removed, yeah, that's you don't hit it till almost 13 inches. So there's going to be a little gap between the end of this and that. And my plan is this sleeve is going to be flush with the inner right here. It's going to come right up flush to the tube. So I won't have any interference putting, you know, that inner seal in and out for service. I hope I put it in there and I never have to touch it again. I mean, that's kind of the way it is most cars, but you know, sometimes it happens. So anyways, that's where we're at. I'm going to cut this and then we'll get right back to you. Whoa, don't fall off, baby. Don't you fall off. There we go. So if there was any debate on how thick this stuff is, look at that. Yep. These tubes, yeah, they're heavy duty. This is what you want. Man, this is nothing like a Jeep Wrangler, man. They're not even half that. I think they're less than half that. So anyways, this did not take more than 5 minutes. I cut 3 sections, just got it in there, kept rotating, and then I had 3 little pieces that were holding it on, and that's what you got to see on the recording, is me just cutting through those 3 little piece sections. And if you're gonna put it on, you gotta ratchet sucker down because it's gonna come off. Be really helpful if you had somebody actually holding onto this knuckle, because I couldn't hold it. Once it gave loose, it was like, it's going down to the table. So anyways, that's how you cut. And then let me get into the reassembly part of this. Okay, well, here we are. You can see tack welded here, and there's also another tack weld on the other side. Once I set the angle, it's all plug welded on both sides. When I slid this in, it slid in really nice and easy. If you look over the top, you can, there's my original line and how far off, the 8 degrees turn. It doesn't seem like a lot there, but it actually is significant out here because this has all this 8 degrees out here, you get an inch or something like that. You can also look down in this groove. Remember I told you I had to, I ground part of this that way. You're losing some of the width because of the grinder wheel width. And then I ground this down to make a gap. So now I get all the way down to that sleeve, plus I get both sides of this as I start to weld that up. So this is with an inner sleeve that's been machined to do this. It really makes this super easy to do. You can see here's the inner tube, and it's flush with the outer tube right there. And the other thing I do, and really to set this, I just took my angle finder right here, and you know, this is a different orientation, but I think I used the magnets. And I just, you can zero it out, and then I just rotate, and then I just rotated it that way, so it's zeroed out until I hit the 8 degrees. And then I just put the big fat tack on both sides so it wouldn't move, and took this off. So no magic to this. And I'm gonna have to say the hardest and dirtiest part, your grinder does most of your labor. All right, so you can see I'm starting to feel the weld on that. Probably one more pass here and then one over with the top, and I should do it. I'm just letting it cool down between passes. But since this is all done and fixed, it's not going anywhere, and the angle that I'm gonna set for the other side is basically, I'll set this to 0, and then the other side, rotate it until it gets matches this one. You know, that's the plan there. So in that case, I went ahead and I did this. Yeah, I did that. I broke it. Cut that sucker right in half. So this allows me to get this piece off from this tube, and then this piece off from that tube. And I cleverly did a jack stand down here. It's kind of balancing itself when I cut it. And then I got another jack stand here to catch it. Boy, having another set of hands would come in real handy. But anyways, it is cut in half. So now I can work on getting these castings off of here. So my theory of, you can see, cut right through the spot weld. This one I had to go at an angle because of the shoulder right here. And then through that spot weld, and then I just kind of came up there because I had room. And it works. Yeah, look at that. So I got one more spot weld to cut through on the back side here, which means both those pieces should come off with a great big hammer. So I'm going to keep at it, and I'll be right back. All right, well, I got the other side done. See, it's off there. This one took a little more work. So right here, yeah, that's yucky, and you should have a glove on. I'm gonna put a glove on. Give me a second. There we go. So this was on there like that, and you couldn't cut up through that bearing support. There's a little bearing in there. And I tried cutting here, but that was too high. So I cut back, what's that, about 3/4 inch more. And then I was able to peel these pieces off of the back. And once I got all those off, you could just take a hammer and beat this, and it just, you know, it's on here and just slides right off. So yeah, that one took a little more effort. I got a little welding cleanup to do on the cuts there. I got a little deep in spots, but you know, there's going to be another tube in here. It's 1/4 inch thick, so I'm not too worried about these too much. Plus I'll weld them up and they'll be all good. Well, so had this thing all cut down, and got the CAD off, and here's where I'm at now. So installed the sleeve on right there. See the little shiny part right there. Then here's the outer, and here's the new sleeve I put in there. Drilled a hole here and drilled a hole over here. Put the sleeve in on the part that was hanging out that I cut off. And then I set it here and just did those rosette welds, or the plug welds. And then what I did is I slid the tube in here, and you can see it right there. Here it is. And then I went ahead And since the driver's side was already clocked, so I'd rotated that 8 degrees. And here you can see this side is 0. So really all I had to do was make the other side match the side I had turned. And there, that's pretty good. It's within a degree, half a degree. In fact, factory, that's all it's in anyways. So it really wasn't that difficult. I'd say the most work here, you got these 2 half pieces here that come with the kit. And it required a lot of extra grinding. The gap here between the tube and stuff was only about a 1/16 of an inch, and it wasn't enough to get the weld wire all the way down to the inside tube. So I ground it back. I got a good 1/8 inch gap, and so on my first pass I was able to get all the way down to the tube, heat that up, and then melt it to both sides. And so right now we're just letting this thing cool off. So anyways, that's where I'm at right now. You can see I'm getting real close. I probably have 1 to 2 more, definitely 2 more on this one, but probably 1 more pass on these. Grind them down smooth, clean them up, and then like the other side, do some touch up. Then keep finishing them. For right now, yeah, this sucker's hot. It's really hot. And I think I exceeded the duty cycle on my welder because it started getting weird. So I'm just gonna let everything cool off, rest, and then restart once this all gets nice and clear. So, and also to do, it's a lot of grinding. I mean, it is a lot of grinding. And these I bought Harbor Freight. This is 36 grit. They also have 60 and 80 grit. And then I just use a regular cut-off grinding wheel for the backer plate on here. And I've been doing all my grinding with this. I mean, it's a ton of grinding, and I haven't even changed it out yet. It still just cuts beautifully, cuts fast. So I highly recommend go to Harbor Freight, look for these discs. And I never did find, there's some backer piece you can buy for your grinder. I didn't even see it over there, so that's what I came up with. It worked great, and I highly recommend it. So I guess I'm just gonna keep going over here, put on the spring bucket, and then we'll get back to you when it's pretty much all sanded down, I think, and ready for paint. So I think that's kind of the next step that I'm headed to. Okay, I did a little bit more and cleaned all of the driver's side up, and I got the spring bucket, you know, and all for the radius arm hookup. Got that on. It's a little tricky because, you know, when you use a plasma to cut, you remove material, and you move quite a bit. So what I ended up doing was just welding here on the edge to build it up so I get closer. I did it in all spots. Even this was way off. You can see there's a huge gap in here, and there's also one here. But I had this piece here, it's welded out, had contact, and then over here had contact, and then this thing with a big booger weld on it. Welding upside down, it started to run. It is what it is. But it's on there, there's a lot of heat. And then, so I thought, well, to deal with these, what I'm gonna do is get a piece of 3/16 plate and just, you know, have the bottom shaped to the radius of the tube, and just do a little overlap and just weld it here and weld it there. And that'll take care of that. And I'll do the same thing down here. I'll just have a little piece of metal that fits in here, and then weld it to the tube and weld the bracket, and that should be that. Now, the other thing I did here, so I went ahead, you can see that's practically 0 in that direction. Oh, you know, that's like the 5th time I've done that. Okay, and you can see this is pretty much 0 in that direction. So I went over to this one, and you can see that's you know, plus about a degree off maybe. Ain't gonna hurt a spring bucket. And that one's like right smack at 0. So these two guys are pretty much level with each other all the way across. I think really now it's just finish welding. You know, make these little patch pieces over here, grinding, welding, and grinding, grinding, and welding. So anyways, that is a Dodge Dana 44 or Dana 60 CAD Delete. The Tahoe Overlanding, I believe, has a CAD Delete for the Dana 60s too. And you can do it one of two ways. You can do it the way I'm doing it, where you actually remove the whole thing. Or there's a thing we got to kind of drill out through here because of the bearing and stuff in there. Then you sleeve it, and you just leave the CAD on. And he's got a whole video on how that's a lot easier, a lot less grinding and welding, I tell you that right now. But yeah, this works for Dana 44 or Dana 60 Dodge with the central axle disconnect. And if you want to cut and turn these, which really, you're turning these, because when you install this back in the truck, your caster, you're going to set it right back to where it was. The only difference is it's now this pinion here is going to be pointed up higher, and you have a better drive shaft angle, all that stuff. So, all right, well, there it is. A total CAD housing delete with a cut and turn to bring this pinion angle up. And that's going to be a really nice straight run to a double cardian, and it's going to be smooth. I have, basically no angle here. Right now we're just waiting for paint to dry. So I think that's it for this, because now it's just assembly. And there is actually one more part to install for this kit. This ring right here. And I'll tell you where it goes. Hold on. Too much light, too much backlight. Get a flashlight. I wasn't set up for this, unfortunately. There we go. There we go. We're getting there. So, what you're gonna do, let me get my flashlight set up. This flashlight has a flaw. So, right in here, this is the factory, it's just silicone bead. You're gonna take that bead out, and this ring is gonna go and press fit right into there after that's out. And you can see it's just the right thickness here, where it doesn't interfere with this surface, because this is where your shims for shimming your differential hit. And the importance of this is this actually allows you then to insert inside here a standard Dana 44 inner axle seal. And it's going to be just like that little machine surface that you see there on the driver's side, but it's going to allow you to do it over here. And the tool you're going to use is the same tool you use to press the seal in. And you're just going to line it up here. We put some RTV around there to help seal it, but it's a pretty darn tight fit. And I'll get that pressed in, and then, but that's all part of assembly. So yeah, this is absolutely possible to do. The difficult part really was just the grinding. There's a lot of grinding. And so you need to get real familiar and friendly with the grinder to get all this welds and stuff all smoothed out, and to try and get your welds ground down, and also cutting the CAD off, CAD housing. That was a lot of cutting. That took me quite a while. And with that note, I'd like to go over one little safety item. Where is my safety item? You know what happens when you clean up? You can't find anything. Here it is. After I had actually removed the CAD, cut it off, it was a lot of cutting. I got a lot of grinding, like in my face and stuff. And then I was spitting big old dark clouds of crap out of come in my nose. And it was awful. So I got me one of these. Regular old respirator, 3M filters all that out. And as big and bulky as that looks, it seals really comfortable. And I'm going to tell you, it's way better than those N95, you know, masks and stuff that everybody wore during COVID. This was pretty good. And the other thing I like about this, I also, you know, we've got acreage here. We got a ton of weeds. You put that 360-day kill stuff down and it lasts about a week and a half. So when I'm spraying, I'm going to be using that, so I'm not sucking down weed spray either. So yeah, just a safety thing. Learned from my experience. I didn't like it. I had 2 days of my lungs hurt, my nose, my face hurt, my eyes were watery until I got it. Because basically all my sinuses were all inflamed. So get that. I actually ordered it through Home Depot. And free shipping. It just showed up at my house. That was really cool. So anyways, that's it for this series. I hope you got something out of it and hope you enjoyed it. So I'd appreciate it if you'd you know, do a thumbs up, subscribe would be great, because there's going to be a big project coming down, not a Tahoe, be a whole nother vehicle. It's going to be pretty cool. So until then, I'm out of here. See you later.